Okay, good morning. Today we have here Freixa. She's a senior postdoc from the Catalan Institute of Aquatic Research, and she has long experience on working on aquatic biofilms. And today she's presenting a kind of summary of different experiments about different impacts on river biofilms. So thank you, Anna, for coming to the presentation at the Institute of Aquatic Ecology.
So thank you for the presentation and thank you for being here today. It's a pleasure to be here in the University of Girona, and today I will explain you I will not focus only on one experiment. If not, I will show you a little bit about what I'm doing, about my research in general. So I will not focus specifically on one experiment, try to explain you a little bit what I'm doing, more or less. So, as most of you know, I'm working in river biofilms. So, these biofilms are dominate the metabolism of river ecosystems and are composed by different microorganisms, as you can see in these scanning microscope pictures, as bacteria, algae, diatoms, cyanobacteria, protozoa, all different microorganisms. And these stream biofilms are stressed for different perturbations. And I specifically study three main drivers. One is the effect of pollutants. One is the effect of pollutants induced stream biofilms. The other is the flow intermittency and the warming. Is both related with the climate change, so how the increase in temperature or increase in the flow intermittency in river ecosystems affect these stream biofilms. So I will show you now two different studies that we did in order to see this impact of pollutants in stream biofilms, and then two more related with this flow intermittency and warming. So, first of all, I will show you this study that we did during my first postdoc in ICRA in the nanotransfer project. This is involved in this nanotransfer project, and this study is focused in the effect of carbon nanoparticles. So we wanted to see, we use this type of mesocosms, as you can see here. So we colonize biofilm inside of these mesocosms, and we wanted to know different questions. One, it was if these carbon nanoparticles are toxic or not for river biofilms. And then we want to see if the mixture with other microcontaminants, like for instance triclosan, biuron, other typical pesticides that we can find in rivers, the combination of these nanoparticles with other contaminants affect or not the toxicity of these river biofilms. So we performed different experiments, and what we found that, especially first, that is that in environmental concentrations that we find in rivers, this C60, that this is the carbon nanoparticles, did not cause effects in river biofilms. But when it was in combination with other compounds like triclosan or other organic microcontaminants, then we observed that this toxicity, it was in some cases increase it, and in other some cases decrease it. This means that, for instance, in the case of some microcontaminants, when it's combination with these two stressors, the combination effect increased the toxicity that we expected. And the other time, in the other cases, we observed that when it was combined, the toxicity decreased. So here I show you some results. This is from extracellular polymeric substances of the EPS of the biofilm. And what we find here in the different treatments that we have it, that is, for instance, the control is not, we don't have without nanoparticles and without microcontaminants. So we observe here that it's not an effect. The C60 was equal, so the response it was not different. But then the triclosan alone, we observed that it was this from the control, it was different. And interestingly, in combination with these nanoparticles and triclosan, the toxicity increase is not an additive effect. It means that increase what we expected. meaning that we name it the Trojan horse effect, that these carbon nanoparticles doing in these organic contaminants. This is a picture of a scanning electron. This is the nanoparticles. So you can see here this is the shape of these nanoparticles. So then I will show you this experiment that we did 2 years ago. And in that case also we used these mesocosms with biofilm. But in that case, we did an experiment with 2 different trophic food chains. We did the first experiment with gammarus and then leaf litter from alder, and then another experiment with Radix balticum as freshwater snail and biofilms. So our idea is wanted to see in this case is the effect of copper concentrations after some days of experiment affect the same way brown trophic food change and the green trophic food change. And interestingly, we exposed this copper from different patterns of arrival. The first one, it was a control that it was no copper. Then we exposed it to a chronic effect with the same concentration during all the experiment. And then in what we name a ham-shaped arrival, that it means a peak of increase of copper and then a decrease during time. Interestingly, at the end of the experiment, the accumulated concentration in the mesocosms, it was the same in the chronic than the ham-shaped treatment. And what we find here is especially that in both cases, we observe negative effects due to the copper concentration in the both trophic food change, but specifically we observe that in the green trophic food chain we observe higher effects or higher toxic effects, and especially in the mortality of snails due to this hand-shaped treatment. Due to these higher values of copper concentrations during 1-2 days only, but during this peak, this it means that decrease totally or increase the mortality of these snails and also the functions of biofilm. So what we conclude from this experiment mainly that it is important to consider the pattern of arrival of contaminants, not only the concentration, if not the accumulated concentration during a period of time, and then also the different compartments. It's not the same one trophic food change that more related with biofilms or snails, or another more related with the decomposer, for instance. No? So we have to consider all of these different patterns and relationships when we are planning this type of experiments. Then I show you here some results of this. Is an experiment that we did in the Alhaz River. This is a tributary from Ebro River. And here we did this experiment just before the pandemics, luckily, because maybe if not we cannot go to sampling. So we did it, and we sampled intermittent and permanent reach from that site at different periods of the year. So we sampled during the contraction, fermentation, non-flow, and expansion period. So this permanent site, it was with water during all the year, and the intermittent site, it was a period of 4 months with no water in the river. So in that case, we can see here the picture of how the river changed hydrologically during the year. So here, for instance, it's totally broke. Here, the appearance of some pools. Here is after a flood, and here it's during the contraction period. So we sampled in that case river sediments at different periods and at 4 different habitats. So in that case we sampled river channel so it's water when it's any, pools when it's any also, and also we sampled dry sediments, the bank sediments, that this is the intersection between rivers and floodplains, and also we sampled also floodplains in all of the periods. And what we did here, this is the results of the PCOA using with the taxonomical unit of bacteria, the 60S RNA. And what we show here, this is the permanent reach and this is the intermittent reach, and the differences between periods. And what we observed here that it was differences between periods, but in the case of the permanent reach, the differences is mainly explained by the expansion period. So when the water, the flood, after the flood. But the other periods, the community composition, it was similar or more similar. And in the case of intermittent ridge, we observed that the community was clearly different between periods. So in the contraction or expansion or non-flow periods or fragmentation period, it was really different community composition in sediments. Here is the results also of the classes, of the main classes observed in the different habitats for the different regions, the intermittent and the permanent region. So also here, interestingly, we find it that in this case, it's including all the periods, the sampling periods together. So what we find here is that first, in the intermittent side compared to the permanent side, we find this higher relative abundance of Firmicute, bacilli, and you cannot see here, but this is bacilli, that this is related with the tolerant taxa, drought-tolerant taxa. Then we find this increase of cyanobacteria in pools in the intermittent side, and also in river, in the flowing waters in the permanent side. And then also this Thermophila taxon, that also it's very common, or we observe high relative abundance in the floodplains, in the dry sediments. So we indicated that this presence of this drought-tolerant taxa also observed in external desical exhaust, observed in these dry zones of the river. And interestingly here, this is a result of Venn diagram. Venn diagram is explaining what we show here. This is the different periods, the expansion, I know that you cannot see it. Expansion, fragmentation, contraction, wherever, and the different habitats, pools, rivers, or wherever we have. And what indicated here is there are only one point, indicated that this number of taxa is only observed in that site and that period. If it's mostly observed in most one, it means that this number of taxa is observed in all of these periods, in all of these sites. No? And what is interesting here, this is a plot of only intermittent ridge, that it means that this tree that is in yellow is number of taxa that are only exclusively observed in pools. It means that this taxa, that is the majority of taxa observed in that site, it's only observed in these pools in a period of time, indicating that exclusively that it's finding, for instance, 165 number of taxa that is observed in the pool during fermentation. This is observed in pool during expansion time, and this is observed only in the contraction time, indicating the importance or the relevance of pools during this process of fermentation, that the water is going the water are decreasing, no? So the flow is decreasing constantly. Okay, so I move now to another different thing. I know that I am planning many different things, but I'm trying to explain you a little bit what we find in each one. So this is an experiment financed by IEA, and this is involved also with Alpasto and Romania that are here today, and is an experiment that we did in collaboration with a lot of co-authors in order to see the temperature sensitivity of river biofilms in the enzyme activities, so in the duration of enzyme activities. In that case, we sampled 5 different sites along the latitudinal gradient, moved from Sri Lanka to Cambridge Bay in the Arctic, so moved to 5 degrees north to 69 degrees north to 5 different sites in order to see differences in the enzyme activities involved in carbon, nitrogen, and phosphorus degradation, 5 different concentrations at 5 different temperatures, 4 to 52 degrees. What we find here, this is the results of the enzymes at only one temperature, and what we find here, this is enzymes related with carbon, also this is related with carbon glucosidase, this is related with nitrogen, and this is related with phosphorus degradation. And what we find here is especially for the carbon enzyme activities, what we found that as increasing the latitudinal radius, so as increasing the latitude, the use of these carbons decrease. So we observe this pattern clearly here in the carbon compounds, but it's not what we observe in the Arctic side, that is that side and that side, that would observe that the activity is higher, and also it's higher for the compound related with nitrogen, the leguminopeptidase, and the compound related with phosphor phosphatase activity, while this Arctic side shows clearly a higher value of what we expect. And results here, it's only showing the results of one activity. This is later glucosidase activity related with the cellulose decomposition. And here, this is the different temperatures for 8, 60, 24, 32 temperatures that incubate the biofilms. And what we observe here, again, this is the 5 sides with the latitude. What we observe here, that is in the Arctic side, we observe a higher sensitivity to temperature, especially on that side, as you can see here, that incubation at high temperature, we observe a higher value, higher activities. So we observe this. Our result is that it's the enzyme activity related with organic compounds showing a decreasing pattern as latitude increase, especially with the carbon degradation, not for nitrogen and phosphorus, and that at higher temperature, we observe that these Arctic stations have higher temperature sensitivity in comparison to the other southern sites. And finally, this is the last thing that I will show you today. I'm not going to boring and saturating with too much information. This is a study that we did it the last year, financed by ICRA, and this is a little bit different. This case is a study more related with management, recreation, and conservation. So nowadays, as most of you know, this is very popular. This is natural swimming holes, or in Catalan, Las Gorgas. So nowadays, many people it's coming there, so they are over visitation, because people it's coming to this place, especially now with these high temperatures that we have it, so many people it's coming to this place, to the Las Gorgas, to swimming. So and there are some places that they have a problem for management, how many people can come to these places and how to increase or decrease, or knowing how many people can come, and then it's not affect the conservation or the preservation of these sites that we really know that are really hotspots of biodiversity. So in that study, we sampled 9 different natural swimming pools from las Guilleries, upstream and downstream of these swimming pools, in order to see if the effect of visitation, so the number of people that come there, affect the water chemistry, biodiversity, and if impact these two drivers, and then if we find it or not, identify the thresholds for defining how many people can go to each of these natural swimming pools. What we observe here is first, this is some drivers of some study that we did with different drivers of recreation in order to see why people comes to one place and not to the other place, no? And we find that especially the number of visitors was higher when it was higher number of river flow, so it means higher water, and then also that it related or linear related with the distance to urban areas, so how much closer it was from the urban areas. And then this is the results of biodiversity impact. This is results of 16S MBNA bacteria. And what we found here, this is only Shannon diversity I show you here. What we found here is this is upstream, up of the natural swimming hole, down of the natural swimming hole. If this arrow is green, it means that increasing the Shannon diversity. If it's red, decreasing the Shannon diversity up to downstream of these sites. And what we observed here, that is these sites, that is La Plana del Duran and Santa Margarita, it was really decreasing the Shannon diversity up to downstream, and it was related with the higher number of visitors that we observed at that site. And finally, in the study, we also observed that we calculate the popularity index related with not only number of visitors, it's not also the Google reviews, the Instagram posts, so different social media resources and calculated this popular index, and we find that as much popular is one site, it means that how most people is coming there, that this is the similarity between upstream to downstream in bacterial community composition was higher. But in that case, it's not following a linear regression, it's following a powered regression, because it is log-log. So it means that in a small changes, so when it was too low to meet changes in the popular index, so lower people is coming there, higher is the similarity between upstream to downstream. And this was one of our results indicating that if the managers want to preserve these special natural swimming holes, have to forbidden the enters of the people to there, because if not, in very short number of people coming there, it was a higher differences in upstream to downstream in bacterial community composition. And then if it's coming a lot of people, so the changes are really low. So when they are a lot of people, the changes between the similarity are not too much. That's it. Finally, I want to say only that the biofilms dominate this microbial life in rivers. Their short relation times results in short-term functional and structural responses to environmental stressors, and are good indicators for study warming, desiccation, and chemical stressors at ecosystem levels. So thank you very much for being here, for listening, and if you have any questions, I can answer.
I have one question. I like very much this last study you showed us. I was wondering, where did you sample exactly for this 16 SRNA? It was really
in the biofilms, in the epilytic biofilms, and in cobalts. So we select 3 cobalts from upstream and 3 cobalts from downstream, but from the river, not from the pool. Yeah, so it means they are river, then the big natural swimming pool, and then continue the river. No, so we sampled just before and after in the river the cobalts.
Okay. Not in the water.
No. Yeah, because we have a really small amount of money, so we decided about what we exactly want to sample in that case.
Yes. And did you check along the year how would this affect the temperature or all these things you were saying in the previous studies?
Yeah, no. Not because only this we did it last summer in July, that we expected that it was when most visitors come there, but in only one time in one day, so we don't sample them. Because actually this is like pilot, I mean only, how to say, experimental design, yeah, in order to see if we find differences or not, because at the end we selected only 9 sites. It's really short our end, no? So small
work.
Yeah.
Okay, thanks.
And I have a question. I was surprised by the very high activity of enzymes in the Arctic side. What might be the reason for that? Because I understood that the graph on the left was natural conditions, and the other one was showing when you were simulating these differences in temperatures.
So these are 16 degrees. That maybe are not naturally in the Arctic. This could be one reason. Because I showed you here this is 60 degrees, so maybe the Arctic usually they are 4 degrees or 5 degrees, so maybe it stimulated too much. So then it's like are showing this sensitivity. I don't know, I answer your question. I mean that maybe if we are at 4 degrees, if we compare 4 degrees here, it's not too much higher, no? Because it's maybe this community is
But I was referring to the other one. Yes, I understand that one. But why? So this is showing the natural enzyme activity, right?
At 60 degrees incubation.
At 60 degrees.
See. So maybe it's not natural. This is that I want to say because it's different.
Okay.
This all of this is results only selecting 16. 16. 1, 6. 16.
16.
Usis, settle.
16. 16. Okay. All right. Okay.
Yeah, so maybe it's for that.
All right. So it's not.
Yeah, natural. Yeah, maybe we have to plot it. Which temperature we sampled, and then this will be different. Yeah, that's true.
Okay.
I also had one comment related to this graph, because you explained the thing talking about latitude, but for me it's not a relevant variable here.
No, why not?
Because I mean you can find many different places in each latitude,
Yeah.
so it makes.
Yeah, because our first idea is in order to see if latitude, it's latitude and temperature, because the idea it was that at higher latitude it was lower temperature, and in higher so I mean this relationship it was related to the latitude, so also. So it's not only latitude, it's not that the community that are there will be allowed to live at that temperature. So this is what we expected.
I understand the
no?
point, but I think.
This is our hypothesis, maybe.
I mean, in Sri Lanka, is there any mountain?
No, actually you can see the river. This is tropical.
So how mountain rivers that you can find
This is
in
tropical. At the temperature there it was 20 degrees, no? 20 degrees over here, water temperature.
And you were visiting the sites?
No.
I
visited.
Why they did this study? Yeah.
Yeah.
Now the thing I was just asking is because I can figure out temperature affecting this, contaminants affecting this, but
Yeah,
latitude.
so maybe they are the drivers, no? You say that.
Yeah.
But probably you were assuming that communities were different in each
For sure.
of the sites.
Yeah, this is completely.
Not everything is
right.
everywhere, right?
Apparently not, but
In that case, I was sampled Arctic, Boreal, and of course, sites. And this one we have co-author analysis and sample this, I think.
so and then in the other graph that you show increase according to temperature. This is also amazing for me, very interesting. I mean, because there's a huge increase in activity, and this I think it's short-term experiments.
See, very short.
So it's just enzyme activity.
Incubation.
It's not growth or production of new enzymes and
Yes.
so on.
Very short, because we did it incubation of 1 to 3 hours. So,
And can you estimate like how they call the energies for activation and so on?
and we don't know. We want to do.
Okay. Because there are very nice graphs for doing such.
See, we have a lot of data here, but we already not.
Okay.
Yeah,
Good.
Photoshop, energy activation.
Yeah.
One day.
Right. Well, you have the data, so data.
See. Then we'll see.
We have very shy guests online, and they are not
Not saying anything.
there to share their question.
I have a question on the very first experiment with the particles that you show this change in the EPS. So then it means that somehow there is a change in the structure, in the biofilm structure. So,
But no, it means lower, no? It means lower EPS there. Could be that it's like the toxic effect that contaminant, no? Too much. Due to the exposure of this contaminant, it was lower EPS. So yeah, would be. This it was 96 hours of experiment. So yeah. So it's quite short.
But I'm joining Anna in asking you, I know, well, sorry about the question, but perhaps you might expect that EPS would increase because of the protection.
Yeah. Right.
yeah, that's what I thought maybe there is kind of a change of the structure.
Yeah,
So
yeah,
the combination
it's true,
of
it's
both is
true.
kind of, I don't know, making the biofilm more dense or thinner or whatever, but because yes, I
Yes,
would
yes, yes.
expect an increase depending
Because
on
it's for the production, yeah, it's true.
I have also a curiosity on this, because you talked about the Trojan horse effect, which I find very interesting also. And how do you separate this from a additional effect? Is there any? I'm
Yes.
just asking to
No,
know.
they are methodologies because you can really, it's easy. No, you know that the effect of triclosan in that case decrease, imagine 2 units. No, this how many increase? How many decrease? It's 1 unit. So it's expected that the combination of both is increasing 3 units. No, because 2 and 1, 3. But it's higher than 3. It means that it's more toxicity that we expect. So they are models that you can calculate that only saying this. If it's higher than the value that we expect, supervising both effects alone, it means that it's synergistic effect that is the same. This is involved in the multiple stressors framework.
But synergistic effect is the same as Trojan horse, or not?
No.
Okay.
Yeah, it's true. No, it's not the same. Horse, it means that what our idea was that the contaminants, it's like
Having no effect.
the contaminants no effect, but when are together, it's like un transporta l'altre per entrar dins, no? Que seria l'efecte del trojan. I seria com aquest efecte seria, esperaríem. But it's true that we don't find this in all of the compounds that we analyzed, because we analyzed 3 different microcontaminants, and we are finding this response in the triclosan, for instance, but not in the diuron and not in belafloxacin, that is the pharmaceutical. So we analyze different compounds and we don't find it in all. So yeah, it depends on the mode of action of each one.